My name's Alan and welcome to Enots Engineering. In this video we'll start the process of making a Warden tool and cutter grinder. Now this cutter grinder is in the form of a kit and was purchased from Hemingway Kits. So we'll go through each stage and the process of making the parts and the assembly. Well, let's start with what you get in the kit. In the kit you get all the materials you need. The metal, cast iron bars, the rods, ground shaft, pressings, cam plates, electric motor, the base unit, supporting rods, the table which I haven't shown, and the plans. This is the base of the tool and cutter grinder. This is how it arrives. And the first job is to fit the two bars that go under here. This is one of the bars. You have to drill and tap the holes on each side to line up with the holes in the top and bottom of the base. When I was tapping one of the holes in the motor support rails, I had the tap break. To remove the tap, I had to cut some of the metal away. Now I need to get the metal welded back to the level and filed off to start again. Just to say that in a set of taps you usually have three. The first one is the one that's got the greatest taper, so that gives you a lead in. The second tap you use is the one that's slightly less taper, and the third tap is a bottoming tap, which is normally for holes that don't go straight through. A bit of vinyl. You turn it back every few turns to break the swarf that collects, and clean it out every now and again to stop the swarf build up in the flutes. You see the swarf build up along the flutes. If you don't remove it and clean that out, it'll jam your tap in the hole, and as I had before, I had one jam where you can't go forward, you can't go backwards without it stopping. So when you try and pull it out, it snaps off. And that's it. We've got all the bolts in, both sides, 8 bolts, all tightened down. Always wear safety glasses when you're machining. These are the glasses I use. They have a reading lens in the bottom half and every time I'm machining I've got these on. Saves you wearing 2 sets of glasses. This is a work table. It arrives with the graduations already marked, and all you have to do is stamp the numbers. The instructions show a simple jig that locates off the 6mm hole for holding the stamps in the right position. I used a CNC machine to engrave these numbers, as I found it would be more accurate and easier to place the numbers in the right position. This is the cast iron sliding block. It will face all the sides to size, then turn it on end and face the 2 ends. Needs to finish at 35. Turn it around. Make sure it's flat on the face. I've turned it round to face the other side of the block, and I've put some sheet steel in there, which is off the top of a tin can, just to prevent the face getting damaged from the jaws. Okay, that's cleaned up on that face. 36 on that end, 36 on that end. So all I've got to do now is clean off the final face down to 31mm. As you can see, I'm using a drilling machine to mill the bearing block. I've marked the centre of the bore and put a pointed centre finder there. Just move it up and check. Actually, it's not far off that. Get the lowest point, 0 there, turn it round to the opposite side, find the lowest point, and then adjust your chuck jaw. Zero. That's a thou. Tighten that in a bit. Zero there. That's half a thou. And this side 0. 0. That's within half a thou. Zero, let's check that it's parallel. Yeah. And now that's centre, ready for going. I've set up the boring bar now. I'm a bit concerned that I've only got 2 screws holding it because it sticks out 3.5 inches. So I might get some chatter on that, but it seems fairly solid. This is where I store my gears for screw threads. At the moment I haven't got the lathe set up to do any feeds, so I want to set up a fine feed so I can put it on automatic and not rely on my turning the handle. I've made these trays for putting the gears on because I got fed up of sorting through them trying to find the correct gear. Each gear I've put the number of teeth in the middle and they're just held, they're oiled up so they don't go rusty, and they can sit there till I need them. Keeps them clean, stops them going rusty. I've selected the gears for the speed I need, and we're looking at 0.3 millimeters per revolution. So that is a 24 tooth gear on the top, 60 tooth gear on the bottom on the lead screw, and then between that a 18 to 72, which is this one, and an 80 tooth gear, which is that one. I fitted them all in. I've oiled the gears in the oil ways, which are these little holes there, the end here, the holes in the middle of the gear there and there. That puts lubrication onto the spindle of the gear. I've adjusted the carriage there so that the gears are not tight, they'll move freely, and that's ready to go. This is the chart for the lathe showing you the different gears needed to give different feeds and speeds. telescopic gauges. The way these work is the ends spring loaded, and on the end of the handle you have a small screw which will lock the top to the bore size you've got. Now this bore on here is 0.75, so I'll use that one. Put that in, bring it up till you get a feel, and you get a feel on the bore, lock it, take it out, then you use the micrometer to get the transfer the size from the telescopic gauge to your micrometer just by feeling. .7525. I think that size. Yeah, it's very tight. Just needs a polish with some emery, and I think that'll be it. I ground a chamfer on the top of this bar just to give me a lead. Let's see. The reason why I'm wearing gloves, by the way, is because with cast iron you do get a black dust off it, and it sends all your skin and hands black, and it's just difficult to clean. So if you're wearing gloves, be very careful not to put your hands near anything moving, because if the tool or something catches the edge of your glove, it will pull your hand into the machine. So that's one aspect you must be careful of. With the block so far, we've machined the 4 faces on the lathe, machined the 2 end faces. In the drilling machine we machined the chamfer and also the cutout, and on the lathe we did the bore. So the next job is to drill the 4 holes and fit the block to the table. Well, thanks for watching. I hope you've enjoyed it, and we'll see you next time on Enots Engineering.